This is chapter 10.1 and it's going to be composite and inverse functions. So before we were talking about different types of functions, we've dealt with linear functions, so functions that look like this. F of x equals mx plus b. This is what we call a linear function because there's only one x. We've also talked about functions that look like this, absolute value functions. This is absolute value. We also have other types of functions like the one with the square root. So this is just a square root. And obviously we have the cubed roots and all these other roots. And then the one that we recently did was the quadratic function, the one with the x squared. In the later videos, you're going to see two different new functions. It's going to be the logarithmic function and the exponential function. But right before we go into those types of functions, we want to talk about composite and inverse functions. So we know that every single time we see the word or the letter f of x, this means function. And further know, this is also our y value. So whenever you see f of x, that just means it's just going to be a y. And how do we know something is a function? Well, a particular graph is going to be a function if it passes the vertical line test. Passes vertical line test. Or for every x value, there's only one y value. So if I give you this particular graph, like if I give you a parabola, this is going to be a function. This is a function because if I were to draw a vertical line right through it, it'll only pass it only once. Okay. However, this circle is not a function because if I draw a vertical line through this particular graph, you'll see that it crosses it at two different points. So therefore, this is not a function. Oops. All right. And we have many different things. For example, a line will be a function. Okay. And also something that is kind of wavy will also be a function. This is also a function. Okay. So we have all these different types of functions and not functions. We know how to classify them. Now, there's something called function composition. And what function composition is, you are going to have two different functions given f of x and g of x. So we have two different functions. They can be quadratic and linear, whatever. What we're going to define function composition is as the following way. So this is what function composition is. I'll write a definition here. So if you have two functions, you're going to have this little symbol, this little O. So it kind of reads as fog. And what this means is f of g of x. Okay? So the way that we read this, and I'll write it in a little bit, what this really means is that whatever g is, I'm going to plug it into x. So this means f of g of x. Okay? That's how you kind of read that. F of g of x. So that means that whatever g is, so I'm giving you g, I'm going to plug it in to the x's that f has. Okay, so whenever this thing is in the inside, that's what we're going to plug in to the outside function. You can call it the outside function. So just be very aware. Don't confuse it with f times g of x. This thing is very different than that thing because this is literally f of x times g of x. So here you are multiplying. So you're multiplying both functions. Here what you're doing, we're going to call this composing. So you're composing because you're putting a function inside another function. Okay, so let me give you a couple of examples. That way you can see where these functions, how these functions work. So given the functions, let's say we have f of x is equal to 2x minus 3 and g of x is equal to x minus 7. So here we have two linear functions because they only have one x. All right, so this is what I want to do with these functions. I want to find f of g of x. That's the first part. Then I want to find g of f of x. And then finally, I want to find f times g of x. Okay. All right, so we have these three different problems that we need to do, and we are given f of x and we're given g of x. Okay, so the first thing that we want to do is we want to figure out f of g of x. Now we can always rewrite this as the following way. We can rewrite this as f of g of x. Okay, so in this case, what I'm saying is that this g of x, I'm going to plug it inside the f of x. So a way that you can think about it is that I'm going to have f of what exactly am I plugging in there? Well, plugging in g of x, and what is g of x equal to? Well, g of x is equal to x minus 7. I'm going to plug in x minus 7 in there. Okay, so let's write what f of x is. Well, f of x is just given to me as 2x, and I'm going to put parentheses there, minus 3. Okay, this part is just this part, this 2x minus 3. And what exactly am I plugging into the x? And then to the x, I'm plugging in this x minus 7. Okay, so all I'm doing is wherever I see an x, that's where I'm plugging in this other function. Okay, so let me just distribute. So I'm going to get 2x minus 14 minus 3. And now I'm going to combine these terms, 14 and minus 3. So I'm going to have 2x minus 17. All right, and that is the function composition. All right, so now let's do these other two problems. So can you try part B? We want to figure out g of f of x. Well, this is just going to be g, and instead of plugging in g of x in there, I'm going to plug in f of x. Okay, so now I'm plugging in the f into the g. Okay, and what exactly is f of x? Well, f of x is just going to be this 2x minus 3. Okay, so this 2x minus 3, that's going to be my f of x, 2x minus 3. All right, now let's figure out what g of x is. So g is just this x minus 7. So I'm going to plug in parentheses wherever I see an x. So here's an x. I'm going to put parentheses minus 7 because this originally was an x. And what exactly am I plugging into the x? Well, I'm plugging in this 2x minus 3. Okay, so all I'm going to get is 2x minus 3 minus 7. So this gives me 2x minus 10. Okay. Notice we're not multiplying anything. All we are just doing is putting a function inside another function. All right, so now let's try the last one. Well, this is just multiplication. This is just f of x times g of x. F of x in this case is just 2x minus 3. G of x in this case is just this x minus 7. So all we got to do is just multiply these things out. So notice that this one had a multiplication sign, a little dot, closed circle. The other ones had open circles. Okay, so let me just FOIL this out. That gives me 2x squared minus 14x minus 3x plus 21. So this is going to give me 2x squared minus 17x plus 21. That is going to be my final answer. Okay. All right, let's do one more problem. Let me write it right here. So, let's say we are given a couple things. Let's say f of x is equal to x squared plus 3, and g of x is equal to 7x minus 1. So one of the things that I want to figure out is what is f of 1. And then another thing that I want to figure out is what is g of f of negative 2. Okay. So you can try these problems out if you want. There's many different ways that you can do this problem. Okay. Now notice what I'm trying to do here is something that you can do. You can first plug in the 1, and then whatever you get, plug it back into the f's, because this is basically saying f of 1. So basically I'm saying plug in whatever f of 1 is, then whatever you get, I'll plug it back in there. So let's figure out first what f of 1 is. So f of 1, all I'm doing is plugging in 1 to the x on f of x. So that's just going to be 1 squared plus 3, which gives me 1 plus 3, which gives me 4. So f of 1 is equal to 4. So this particular thing is just equal to 4. Notice I still have an f on the outside, which means I'm going to re-plug in this 4 back in there. So it's going to be 4 squared plus 3. That gives me 16 plus 3, which gives me 19. And that is my final answer. Now, something else that I could have done alternatively is I could have first found what f of x is. Okay? So first, f is just this x squared plus 3. Okay? And what exactly am I plugging in? Well, what I'm plugging in is f. So basically, I'm plugging in this function in itself. So I'm plugging in this x squared plus 3 inside of it. Okay? So you don't even need to FOIL it if you don't want to, because now all we got to do, now we know what f of x is. All we got to now plug in is just this 1. So this is going to be 1 squared plus 3, whole quantity squared plus 3. This just gives me a 4 squared plus 3, which gives me 16 plus 3, which gives me 19. So still gives me the same answer. So whichever way you want to do it, that's just up to you. Now let's do this last problem. This is going to be g of f of negative 2. Okay, so maybe it might be easier to just find what that is. So let's see. So we're going to have f of negative 2. I'm going to first plug it into f, which is this thing. So this is going to be negative 2, don't forget these parentheses, squared plus 3. This is going to give me 4 plus 3, which gives me 7. Which means that f of negative 2 is equal to 7. So now that I know what that is, I'm just going to plug that in here, because this thing is just g of 7. Now I'm going to plug in 7 wherever x is on the g function. So this is going to be 7 times minus 1, and whatever's in the inside, I'm going to plug in this 7. This gives me 49 minus 1, which gives me 48. Okay? And that's all there really is to these function compositions. Not hopefully too terrible.